Today we are going to talk about a problem is to reverse the banner tree upside down. This is the problem. We are given a banner tree with a banner tree like this one. This is a banner tree where the all right notes are leaf notes. Like this one, they are both leaf notes. They don't have left and right children's. They are left and right children's are both none. We need to flip it upside down and turn it into a tree with left leaf notes as the root and return the bottom left note as the new root. This is the bottom left note. The left leaf notes as root. This is the root. This is this can also be see a root. Can also note 2 are being seen as the root for note 1 and note 5. And note 3 is the bottom left note are seen as the whole root of the root of the whole tree. Like this. The result of flapping it like this. Then we rotate the tree into the tree. We see it easily, like this. Like this one. But how can we do to make it into this? My idea is that let me see. I think my idea is to build from the left bottom node, like this one. As long as we find this node, we can make it left children to be 2 node. It's right children to be 4 node. How can we find it? We can just go down until the 3 node 3. But when we rebuild the tree, like make node 3 left to be 2 nodes, node 3 left right to be 4 node 4. We need to have the node 2 first. So when we getting back, we also have to look back to get this node. This led me to think about a structure like stack. It have a feature like look back. Because when we put one, it's first in and final out. Like if we put 1, 2, 3. One node is the first come in, but it's the final to come out. This is the feature. How can we use stack to solve this problem? We first go all the way down the left part of the string. Let me give you the new original tree to better to talk. It's the same with the original tree, and I think first we can just go all the way down the left part of the tree, because the bottom left node will become its new root. When we're going down, we can just because we also have to look back. When we're rebuilding, we also have to look back. So we have to start when we first going down. How to start? We can just use this stack. Like 1, 2, 3. Until 3, this left is none, so it means that we have arrived to the bottom left node, bottom left leaf node. It's the root, the new root. First we can just pop the new root, pop the new root out and recall it. Then we can keep popping the nodes from the stack one by one and reconnecting it. The nodes will become the children of the previous. How does it mean? Like for each node we pump out, like the node 2, the node 3 we just pumped out. We can set its left children to the next node we pump from the stack. The next node is node 2. We can just set 3's next left node is to be the next pumped node. Just node 2, like this. And from this, let me change a color. From this one, we just add a link, like this. Make the node 3's left children to be node 2, the next pumped node. Then we would put the node we pumped out. It's left, but it's right children to be the pumped node. The next pumped node's right children. Like 3's right children can be, look at this one, can be 4. Because the 4 is originally the node 2's left children. So we make the next pumped node right children to become its previous pumped node's left children, like this one. Now we just finish. We can see it like a phrase, this phrase 1. Then we can continue to pump, because the next pumped nodes always become its previous node's left children, and the next pumped node's right children will always become its previous node's right children. So for the node 2, its next pumped nodes is node 1. The node 1 will become the left children of node 2, and the node 1's like this one, like this, and this node 1's left children, 5 nodes will become the node 2's right children, like this, node 2's right children, as we have done in phrase 2. This can be C phrase 2, like this is phrase E, it's the phrase 1, this is phrase 1, this is phrase 2, like this. Then we just then we can know that we continue to rebuilding the tree from the bottom. We just continue to building the tree from the bottom, the 3 node, until the first node, the root, the original root. This is new root. For this, we can just rotate it. It will become this one, like this. But we still have to notice that the original root 1. Oh, sorry. The original root. Let me change a color. The original root. It's a link with node 2 and node 4 because originally the node 2 is the left children of node 1 and the node 5 is the right children of node 1. So we have to cut the link before originally. Then how can we do? Just make node the left to be 9, node 1 the right to be 9. Then we got it like this 9, this 9. Then we got the result like this. This is the result. Can you understand? Maybe from this we need to cut, because if we don't cut, it will become a cursor. Like because before the link is like this, they will form a cursor. This is they will form a cursor. So we don't have the cursor. We need to cut this. This is my first time to talk about the problems in English. If you still have some questions, you can just let me know in the comments. If you have some bad suggestions about this, welcome to give some useful comments or suggestions.